whatever I'm speaking today, it is based on an ongoing research project with the Florida Department of Transportation here in the United States. And Dennis is the one who has been working on this research project. So the slides, if they're pretty, thanks to Dennis. If they're not, then it's on me. So when I was asked to talk about a topic, AI in transportation engineering, I know that I definitely want to talk about the existing AI applications and potential AI applications. But before that, I thought that maybe I would like to talk about where did we start with AI and where are we heading? What is the timeline of AI adoption? And from my perspective, what are the three generations of AI in transportation? We all agree that the latest buzzword is AI. We are either scared, excited, anxious, or skeptical about AI. So let me ask you a question. So can AI predict where the next crash will occur? Yes, maybe, but yes, definitely yes. Can AI help design safer roads? Yes. Can AI optimize traffic signals across an entire city or a state? Yes. Can AI replace a transportation engineer? For that, I believe that the answer is no, not in our generation and not in the immediate next generation. That's what I think. However, I want to have a caveat there that the transportation engineers who are proficient or comfortable with AI might replace the ones who are not comfortable with AI. So AI is here to stay. So we might as well just accustom to it and look at how we can use AI applications to improve safety and mobility on our roads. So again, when we talk about transportation engineering, what are the two words that come to your mind when you want to explain what transportation engineering is? The two words to me that come to my mind are data and decisions. If I have to explain to my mom what we do as a transportation engineer, I would like to say that we use data to make decisions. And when we say that, what data are we talking about? We're talking about traffic counts, speed data, crash data, travel time, traffic models. And these are all the data that AI would be using in order to help make informed decisions. And by decisions, what decisions are we making? We are estimating demand using counts, identifying safety problems where people are speeding, identifying high crash locations, evaluating conditions. All of these decisions are based on data, and that is where AI is strong at. So the next question that comes is like, did we all wake up one day in 2022 and AI is flip a switch and AI is all around us? No. So when we look at the timeline, which I kind of like to credit, and 1950, that is way before I was born, between 1950s and 70s, where the transportation is just really getting started with at least in the United States, with the interstate system, it is the humans that we define the rules and we drive the transportation engineering. And later, what we got are calculators and computers, Excel. I'm sure you still remember Access. MS Microsoft Access, and we have AutoCAD, Civil 3D, etc., where we are using computers to do the most of the calculations. And later, in the later 1990s and early 2000s, we have the ITS. And now comes the most interesting or exciting part, where we have the machine learning, the deep learning, computer vision, and more recently, the generative AI in the last couple of years. And what the future holds? Autonomous AI, where AI is going to learn from the decisions and help us, or maybe even make the decisions for us. So with this, I'm going to skip a couple of these slides in the interest of time. So when I think about AI, I do not believe that AI just came yesterday or last year, and it has been around. It's just that we did not know it as AI. The first generation, I would call it, which was maybe at least 5 to 10 years ago, we have the first generation where we are predicting crashes, predicting traffic, pattern recognition, video processing, automatically identifying dangerous locations for safety improvements, and automatically counting traffic. And this is more what we have, or maybe a couple of years ago, which is signal optimization, dynamic routing, dynamic tolling, incident management, automatic incident detection, variable speed limits, variable tolling, transit scheduling, and also work zone management. And we have the upcoming, or where we are stepping into the third generation, where we do have autonomous vehicles, connected vehicles. We also have adaptive traffic networks, AI integrated or AI controlled intersections where the traffic signals are completely controlled, or signal timings are changed by AI based on incidents, planned and unplanned events, weather events, etc. So, what does it take in order to have or deploy AI applications? So, the first thing that we need, if we are to deploy any type of AI application, is data. Data is a new oil. It is a new currency. The person or the agency that holds access to the data is the one who is going to make significant improvements or changes. When we talk about data, it is not just CCTV cameras. We have data, as the previous presenters talked about. We have GPS data, we have data from roadway sensors, we have transit data, weather data, crash, connected vehicles, drones, etc. But having the data itself is not sufficient, because we need models or algorithms, right? We have machine learning, deep learning, computer vision, natural language processing, the generative AI, and reinforcement learning. And with the algorithms comes the most difficult part, which is the computing, where we have cloud computing, edge computing. And we do all of these three things in order to make transportation decisions that are to improve safety, mobility, accessibility, improve operations, and sustainability. So I have, again, when we talk about yesterday, what we have with respect to transportation system, what we had yesterday were roads, vehicles, and signals. Simple. But right now, at least in the United States, I'm sure it is the same case with Tanzania as well, is that we have a lot of other infrastructure on the roads. We have sensors, we have cameras, we have connected devices, and also we have a lot of data. We have crowdsourced data, we have data collected from detectors, from sensors, cameras, and other data sources. And tomorrow, the future, what we have is we're going to combine all of these sensors, cameras, devices, etc., and club them as one, which is the infrastructure, which is, you would say, Internet of Things, and then we have the artificial intelligence, and then we have the humans in order to who work with AI in order to make the most efficient decisions to improve safety and mobility on our roads. So where are we headed? We are headed towards a predictive environment where we are not going to wait for crashes or congestion, but we predict them beforehand. We are heading towards an adaptive environment where transportation systems, such as, say, for example, the simplest example that we can relate to is traffic signal timing, which continuously adjusts to the existing conditions, or dynamic tolling. And we are going towards a perceptive environment where AI understands what is happening, and we as humans do not feed in the information to the AI model, because it has the capability to extract the same information and infer from it through the cameras, sensors, and connected vehicles. And also next, we have the generative AI, where AI becomes an engineering co-pilot who works alongside the engineers. And finally, we have autonomous AI, which moves from recommending decisions to actually taking action. So, I've provided a little bit of background about AI and where we were and where we are heading. But in the next few slides, I'm going to quickly go over some of the existing AI applications in transportation engineering. As I mentioned, this is a part of a funded research project, and one of my students was actually from Tanzania, Dennis. He was working on this. What we did was we surveyed all the state departments of transportation, all the 50 states, to identify if there are any AI applications that they're using in transportation engineering. And in the next few slides, I'm going to quickly talk about these applications so that you can start thinking about how these applications could be deployed or adapted to Tanzania. The first application is a wrong-way alert system. This alert system, what it does is it prevents head-on crashes caused by drivers who are going the wrong way on an interstate or a freeway or a highway. So what it does is, like, it reduces these collisions by detecting the vehicles that are going the wrong way, and or not only that, but issuing warnings or informing both the wrong way driver and the people who are driving the right way in real time, and also informing the police and the first responders to mention that we have a person who's driving the wrong way. We need to be, intercepting them as quickly as possible. And the AI technologies are like computer vision and anomaly detection. We do have an asset management which was being deployed by Hawaii DOT. What it does is to track, evaluate, and maintain roadway infrastructure like the pavement, signs, pavement markings, guardrails, etc., so that to make sure that they are in a serviceable condition. For example, we have millions and millions of miles of roads, of lane miles in the United States. For example, in Florida alone, we have about, I think, 2 million local miles of road. So it is almost next to impossible to keep track of which pavement markings, which signs on which roads are need improvement or need to be serviced or repaved or remarked, right? So what Hawaii is doing is like it is using the aerial images from the satellite images and computer vision in order to identify locations where the roadway infrastructure such as pavement, signs, markings, guardrails need improvements or need to be replaced. We have Citian. It is a crash application which was deployed by Minnesota DOT. What it does is like it uses AI in order to clean, geolocate, and visualize crash data into a map-ready database. I'm assuming again, I've never been to Tanzania, but my students they work on crash databases or crash records from Tanzania, and I believe that this application would be very apt and adaptable to the roads or crashes in Tanzania because data cleaning and geolocating is quite resource intensive. We have utility mapping, which is a very interesting AI application, which is not really transportation related core, but it helps with the transportation for the transportation sector, which is using AI to map the subsurface utilities to support traffic safety by identifying the underground utilities so that when you have a bulldozer coming to dig up the ground, they know where the underground utilities are and where the work zone risks are. Again, this is also a part of the data acquisition and data maintenance part, and IODOT is working on is using this technology, this AI application. We have AI-based decision support system. Along the interstates in the United States, several agencies focus on integrated corridor management, where the goal is to improve the safety and operations on these limited access facilities, and also reduce the travel time, reduce the congestion. So what Tennessee has been doing is like it has been using AI, the multi-agent reinforcement learning and machine learning, in order to use or to deploy the lane control signs, ram meters or dynamic tolling to make sure that the traffic runs smoothly and safely on these corridors. This is not a statewide deployment per se. It is just on one corridor, I-24 corridor. They call it a smart corridor because it is equipped with all the sensors that we can think of, and it is in Tennessee. We do have an automatic incident detection. This is being deployed in Georgia by Georgia DOT, where the agency is using computer vision and CCTV cameras to automatically detect an incident. So instead of waiting for somebody to call 911 or to call 511 and report an incident, because it will be too late to send some police or some EMS, emergency medical services. So in Georgia, what they're using is they're using real-time camera feeds from CCTV cameras to identify and detect incidents automatically and act on them. We have in Florida, this is one is in North Carolina, we have the real-time intersection performance monitoring, where the one exciting thing about this application is that in North Carolina, they are using this AI traffic signal optimization across over 2,500 signals. Imagine the scale and scope of this project, where almost over 2,500 signals in North Carolina are being optimized using AI. So this would help with real-time monitoring, issue detection, so to improve the mobility, reduce the travel time and congestion. We have one more application, which is Heidi, which is the high definition engineering intersection data. This is within Florida, in the Orlando area, that would be the central Florida, where they are using AI to count in real time the turning movement at signalized intersections. So that data could be used later on for signal optimization, condition management, and safety focused operations. Again, the way I see it is like Florida DOT could use this application in order to do the real-time turning count and feed that into the real-time intersection performance monitoring system, so that everything could be the entire signal operations within Florida could be automated and improvised. So quickly, the summary of current AI applications. Again, this is just for you to just get a very high level overview of what AI applications are currently being deployed in the United States. We have the wrong way alert system to prevent head-on crashes caused by wrong way drivers on freeways. We have asset management to track, evaluate, and maintain roadway infrastructure. We have city and crash to draw insights from raw crash data records. We have automated incident detection to detect and verify incidents in real time automatically using CCTV cameras. We have subsurface utility technology to identify underground utilities so that they don't be cut off when a road work or work zone is in progress. We have AI-based decision support system, which is to improve highway performance, safety, and mobility along a specific corridor. We have real-time intersection performance monitoring to monitor intersections and detect incidents at signalized intersections or in urban areas in real time. We have Heidi, which is to obtain real-time turning movements at intersections. So this, whatever I just discussed or mentioned so far, are what are the AI applications that currently the United States are pursuing. But what I want to have, the next slide, I'm almost done, is to identify what are the other potential AI applications that could be used that are not what was discussed up until now. And I wanted to identify these potential AI application use cases, if you will, based on the data. So once we have the data, we could identify or see how AI algorithms and models and computing power could be used to analyze or process that data to come up with a meaningful use case. The first one, the most commonly available data is the CCTV camera feeds. And this feed could be used for incident detection, which we already talked about, but we could also use it for end of queue or rapid slowdown detection. It could be used for identifying work zone intrusion, for vulnerable road user detection at intersections, which will be pedestrians or bicyclists who are jaywalking, kids who are running across the street to go to McDonald's on the other side or to go to the school on the other side. We also have AI-based railroad crossing safety and obviously wrong way driving detection, which we already talked about. These are the applications using CCTV cameras. And we do have some of the applications that use traffic volume and congestion data, which would be traffic anomaly detection, which was also discussed earlier in the day. And we also have the AI-based predictive traffic management system. When we use using the detector data, we can predict traffic conflicts. You can identify traffic anomalies, and we also can use the identify or detect vulnerable road users, that is the pedestrians and bicyclists, not only who might be jaywalking at a signalized or an unsignalized intersection. And we do have other data sets that are not that common or not that traditional within the transportation sector, where we could use data from, in the US, we have NOAA, which is the weather data, to use the AI-driven weather response traffic safety or evacuation routes in the case of hurricanes, tornadoes, etc., where we could use AI-based evacuation routing and decision support system. We could use AI-based infrastructure risk and pavement defect detection. Again, these are some of the potential AI applications that could be drawn from the data that we currently have in the United States. And bear with me, this is my last slide. So I do have some food for thought. I was wondering that, having listened to all the AI applications that are currently being deployed and potential AI applications, what do you think? Which of these AI applications can make sense for Tanzania now or today, and which require infrastructure that Tanzania may not yet have but would aspire to have in the coming months or years? So I believe that most of these AI applications are very much adaptable or untransferable to any region or any country. All that is needed are good models and the data in order to train the models and then to do the prediction. So, but with that, I would like to take this opportunity to thank you for giving me this opportunity to talk about the AI applications in the US. So thank you, and I'll pause here to see if you have any questions.
Thank you very much, Professor Alur. Ladies and gentlemen, please join me in giving our speaker a well-deserved round of applause. Professor, can you hang around? We are just starting a Q&A session. I've been informed we are seriously running short of time. So we had 30 minutes for discussion, but we are going to try and squeeze it within 10, 20 or 15 minutes. I was informed that you are supposed to submit your question through this. So organizers, when I try to access, I'm asked for an event code. I don't know whether others have managed. There is an event code. Oh, really? Okay. Then, okay. So, audience, I think there is this QR code on your tables, I guess. So if you want to ask a question, then you can. There are already about 5 questions, okay? Okay. 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 Okay, so Professor Sando, can you come in front? I'll be standing so you can sit there. Yeah. So the first question is from Dr. Stefano. I think it's directed towards Professor Sando. Can you please share your experience on the use of technology like drones, specifically the legal framework as smart logistics? Just have a seat, and then I'm just trying to read questions, and then there is another question to Dr. Stewart. Can you explain your research in simple, non-technical language? What is main solution? What is main solution of the AI-ready data reuse? Okay, and then there's a question to Rasa. How efficient and safe are the automated trains in case of accidents? Who will be held responsible if the train is 100% automated? Let's start with those questions, 3 questions, starting with Professor Sando. Is it working? Switch it on.
Hello? Yeah, so the question I believe is they want me to give some insight on the use of drones in transportation engineering. So I happen to be one of those people who use drones for data collection, for traffic data collection. As a matter of fact, Professor Priyanka Alluri that just finished presenting, one of her students, Amy Aima, just came to Jacksonville, where I live, to collect data using drones, I think just like a month ago. I work with a group. So Dr. Aluri is one of my colleagues. You see, she has a lot of Tanzanian students. You heard some of my students present some work on marine freight. So we collect data using drones. So this is what happened. Number one, in the United States, for you to be able to use drones to collect data, first of all, you have to have what they call a drone pilot license. So my students normally take an exam and they become drone pilot licensed so that they can be allowed to collect data using drones. So once they have a license, then there's an app and there are regulations that are supposed to follow. For example, you are not allowed to fly a drone within 4 miles from the airport. It has to be at least 5 miles. But there's an app that will show you the restricted areas. You're not supposed to collect data close to the military base and so forth. And normally what we do is it doesn't allow us to collect data. We can fly a drone, but the highest we can go is 400 feet above ground. So that's what we do. We collect data using drones, and it's more effective. Just imagine if you were to collect traffic data or to do traffic data monitoring at the junction Mwenge and Samnujoma. It's going to be very hard for you to just do manual data collection or to have a camera, but if you have a drone, you can fly it high enough that you can see very far, you can see all the queues, you can identify the length of the queues, unmet demands, and a lot of other traffic metrics that are hard to find using just a normal camera or doing manual data collection. I want to mention though that there are some limitations of using drones. Number one, most of drones have a battery that lasts only 30 minutes. So if you're collecting data for a few hours, you need to have multiple drones so that you can, when one comes down, another one goes up, and you can mosaic the data so that you have data for a long time, so that you can collect data during the peak hour and beyond that peak hour. But other things about drones, I know other speakers also have to respond to questions we can discuss during lunchtime. But I'm more than glad to discuss with you and to collaborate if we have to do anything with drones. Now, some of the students that you saw, they are computer science students, and we have developed computer algorithms that if you give us drone footage, then we can collect we can produce a lot of metrics that we use in transportation engineering.
Thank you very much, Professor Sando. The second question, I don't know, it's directly to Dr. Stewart. Who did you meet? Sarawat. I think it's Sarawat, isn't it? Yeah. Did you understand the question? Did you understand the question?
Can you repeat the question?
Yeah, it's. I think it's mistyped. So I will try to. Question to Dr. Sarawat. Can you explain? It's not explain, but can you explain? I interpret. Can you explain research in simple, non-technical language? What is the main solution of AI-ready data in engineering? Something like that, but that is my interpretation, but there are a lot of typos, so I can't. Okay. But if you can respond to that briefly.
Okay, in simple terms, my solution to my research is, we know we have the transport data, and in our case, the traffic data. So the traffic data is very useful for AI analytics. At the moment, we can collect new data, large amount of new data, but we know this process is very expensive and costful, because when collecting the traffic data, we have to use the sensors, and in developing countries, that can be a problem. So for my case, I dealt with data scarcity environment, like especially Dar es Salaam. So my proposed architecture come in handy, because our architecture is a way of organizing and cleaning, integrating, and reusing this data so as to achieve different ITS tasks. So because this proposed architecture is made up of different layers, so through these layers from the acquisition, we can achieve a synthetic data set, and from this data set, we can be able to do different ITS tasks, as I have demonstrated, like the traffic congestion, the anomaly detection, and as well as the incident anomaly detection, etc.
Thank you very
that's all.
Oh, thank you very much. So, Dr. Urassa, I think there are, there's an additional one. The first one was how efficient and safe are the automated trains? In case of accidents, who will be held responsible if the train is 100% automated? And another one is, I would like to understand, since your TPP framework was tested and recommended for deployment and evaluation within the European railway network, could it also be actionable and applicable in addressing the challenges facing Tanzania's railway sector? So, if you can respond to those briefly, 2 questions.
Well, thank you.
I think they are running short of batteries, so you can use the lectures.
Yeah, thank you for your question. That's a very thoughtful question. And I'll begin with the first one. How efficient and safe is automation? What I can say is the driverless train is not a new thing in railway. We do have a completely full and autonomous train, unattended train, that they're operating without a driver. And the reason is we have a full fenced train and a lot of protection system. And for now, in case of accident in railway, it can not really caused by human error, because there's a lot of safety layers, because the railway safety is very first important thing in railway. So there's no compromise in railway safety. So the thing is, we are trying now to translate the technology which we are having in a metro, for example, which is currently running in an autonomous system, to this open network. So in terms of efficient, I guess we will be more or less the same as in metro system, which also run in full autonomous. And the second question is who will be responsible in case of accident? Well, if accident happen in railway, as I've said, it's not really caused by human, because there's a lot of protection system. There's this ETCS, CTCS, they are very sophisticated system which prevent human error. So even in case of train drivers on board the train, driving the train, if accident happen, it's not the one who is responsible, because it could be something else which is way beyond our control, like, let's say, landslide or some other natural hazard. So I can't really say who will be responsible, because even at the moment, when the train driver is on board, still, we don't know who is responsible, because it's something like natural catastrophe. Don't know if I've answered the question?
Yes.
Thank you.
I believe so. So we are running short of time, and I think those were the only questions. Some more have come, but I think we should close. We're running short of time. So to our presenters online, we thank you very much for taking your time and presenting your papers. Thank you very much. Audience, let's give ourselves a round of applause for the session. I will now hand over to organizers for housekeeping issues. I think explanation regarding the lunch, etc. Thank you very much.
Sorry, presenters, wale walio present session, please. Presenters, can you come back on the stage, please? presenters of these sessions, please, can you come back on the stage? We just have a group photo for our first session.
Wametuthibitisha nchini kimataifa ya TANAISA, wametuthibitisha tunalea mabingwa wa usafirishaji. Ni ya iti safari ya mafanikio, chuo cha taifa.